Okay, good morning, everyone. Today we're going to go over the second um, tutorial on some of my 3D printing processes. These aren't in any particular order. This one I just thought would be interesting because it's a um, project that I'm doing for a friend that is um, kind of involved and a little bit complex, so I should be able to show off several different techniques in the midst of this that kind of give you a little bit more detail on some of the more advanced things that we can do. It's still kind of a fairly simple thing that we're building. So yeah, let's begin. So the plan is my friend has a paintball visor, right? So this is the top of the mask where the lenses go. And I guess this is the frame, is what it's called. And the idea is that he kind of wants me to take this frame and build a cover that goes between the top of the frame and this visor here, right? So we've got this visor. Let's see. We've got these kind of spikes, and those spikes come down and they rest in these holes on the top of the frame here. And he wants a cover that kind of goes over this and rests between the visor and the holes and kind of keeps rain from getting in the back of the mask. So we're going to see what we can kind of build for him. We're not going to try to model this whole thing in Fusion. We're just going to try to model the cover and see how it comes out. Um, so to begin with, we need to get an idea of how we're going to go about doing this. And I have an idea of what I want to do, right? Because basically this thing just comes and it pops down. I think there's a large center hole, and that should allow these to line up with other holes in the back. Yeah, right there. And then it just kind of snaps down in. Very elegant. So all we really need is a cap that sits through the pinholes right here and just kind of rests on top and maybe just kind of snugs into these flutes so that way the whole thing sits tightly. And then yeah, kind of arches back a little ways just to kind of give that bit of rain coverage on the back of the mask. Now, I think based on his requirements, he wanted me to slope it backward so that the rain doesn't flow forward into the goggles and onto the front of the goggles, and instead kind of slides just back onto his head, which we can do. So, yeah, so let's see. So let's begin. So we'll pull this back off. And now what I want to begin with is just a sketch of the profile of this top plate here. So we'll see if we can get that. We've got our calipers here. I think I changed the battery, so we should have numbers now, which, yeah, you can now read the display. It's going to be kind of difficult for me to work with this upside down, so bear with me. When I take measurements, I'll try to at least allow it to stabilize so that you can turn your phone or monitor or however you roll enough to actually read what the display is saying. So let's get started here. Okay, so we've got our workspace here. Now, let's see. Recent data, I don't actually have. Okay, so I have 9 out of 10, so I have one extra active model. So we'll go ahead, and the first thing we'll do is we'll save this blank untitled project as what we're trying to make. So I have a special folder for weird stuff called ends and odds. So we'll save it in there, and we'll call this the paintball goggle rain cap. And we'll just save it. So now we have a saved empty blank workspace that we can work in. And now we'll begin by creating a sketch. And this will vary depending on kind of what your purposes are, but we're going to try and keep the orientation somewhat true to life. So the top of the visor, right, is this surface right here. So if we're making this plate, I'm going to use the ZX plane, so that way our top kind of remains oriented as the top in real life. That's just a personal preference. You could use any orientation you want, but this is the one that makes the most sense to me. So now we have two arches here. We have kind of the back arch, and we have the front arch right here. So we're going to kind of want to get a good, accurate representation of that. So the way that we're going to go about that is we're just going to probably take, let's see, there are special ways to do this, but we might just take and assume that these are half circles, and then we'll take a radius or a diameter from one side of this thing to the other. So we'll make sure, start by zeroing our caliper. So we'll collapse it all the way down and then hit the 0 button. There we go. And then we'll take our measurement. Got to be a little bit careful when you're using calipers just to make sure that you don't introduce any error by sliding the caliper. Okay. So we'll take our first measurement here. And it just has to be kind of a rough measurement. 3D printing isn't really precise, but we just want to make sure that it's kind of in this relaxed, unflexed state. And it's almost perfectly 6 inches, which is good. Now another thing that we can do is we can take a straight edge. And then now would be a great time to kind of wish that I had a straight edge. Let's see here. For lack of a better straight edge, we can use this purple folder here. And we can kind of put it against the back. Now, if this is a 6-inch radius, or a 6-inch diameter, it should be a 3-inch radius from here to here. So we'll just confirm that real quick. And if it's not, then we can do a 3-point arch instead of a circle and kind of correct for that. Okay, so 2.7, 2.785. So yeah, not quite a full circle, but that's good information. So let's see. We'll set that aside, and now we'll make our arch. So we'll go create, and then arc, and then a 3-point arc. And what I kind of want to do is I want to just stretch it across, and I want the center to be our center line here. Okay, and now I'm going to be using hotkeys, so I just use the escape hotkey to close out of the tool, and now I'm going to hit D to go into dimension, my dimension tool, right, which is also right here. So they do the same thing, D or using the dimension tool. Now, we'll set a dimension from this side, and we just measured this. Well, okay. So to start with, we'll change our units to inches. And now we'll go back to our dimension tool, and we'll make our measurement from here to here. And we said this was 6 inches. I think 6.05 is actually what we measured. Excellent. Okay. And now we want it to kind of rest on this line. So what we can do is we can make a construction line. So we'll use our line tool, we'll make a line, and then we'll hit X. And what X does is it turns it into a construction line. So now the program will not consider this line when we go to do extrudes with the profile that we're making. Okay, and then we'll do some things. So we'll make sure that this is coincident with the center, or with the origin, and then it still can slide left to right. So what we can do there is we can also make this the center line, midpoint. There we go. Don't need that. Don't know where all these extra lines came from, but there we go. And then the last thing we can do is constrain this horizontal. All right, and now we need to take these 2 points and make them coincident. So we'll go coincident there, and then we'll need one more construction line going this way. Same treatment. And then the thing is we can vary these, but that's fine. We just want them nice and long. There's no, I mean, they're construction lines, so they're for our usage, right? Not the end user. So, and then we need to make this the midpoint as well. Okay, so it didn't like that. So another thing that we could do, we know that our dimension is 6.05, so if it doesn't accept a midpoint, what we can do is we can just go from the outside, and we can just say the distance from one edge to the center is half, right? So actually we could get really fancy and we can say equals this dimension times 0.5. And then that creates a relationship times d1. There we go. I guess we don't need that equals sign in there. There we go. And now we need this, and we said that this was like 2.78 or something. Come on, be nice. .78. No. Okay, it's gonna. I see. Okay. So I guess we'll take and put a point there. Now, can I make the distance between here 2.78? 2.78. There we go. So that's our first arc. Now we'll kind of clean this up by pulling these out a little ways. Make that a little longer. Okay. So now we got to do the outer, right? So the outer, my calipers might not be able to take some of these measurements. So yeah, it looks like we only go to 6 inches with the calipers. Alternatively, we know the diameter of the inside circle. So what we can do is we can just kind of take and measure from the inside to the outside. So we got 0.575 or so. So all we need to do is on our new arch, it will be 6.05 plus 0.575 times 2. And that's our new diameter for the outer. And then we'll do the same thing. We'll just take our measurement from the back. To the front. Move this in just a little bit. I'm on my keyboard, always a risky proposition. You'll see the calculator going crazy. And once again, that's 4.2 inches. So we'll save that measurement. And then we'll go, what do we say, 6.05 plus 0.575 times 2, 7.2. Okay, so 4.2 is not the same as 7.2 again, so we've got another arc to make. So let's go ahead and do that now. We can save. Don't forget to periodically save, just in case you don't want to lose any progress. And then arc, 3-point arc here, here, and here. Now we said from here to here was 7.2. And we want this. Same trick is this times 0.5. Then we'll set our point at the top. And this to this is 4.2. There we go. All right, and now, yeah, we've got two mostly constrained. The program claims that these are not constrained, but I'm going to posit that they are. So yeah, that's kind of a rough outline of what we're going to be working with as kind of our datum structure, our datum surface. So yeah, that should correspond roughly to this top plate. Now, of course, there's some differences. There's some edging here. It's not a direct straight across, but that's okay because we're not trying to match this perfectly. We're just trying to rest something on top of it to kind of give the end user some coverage from rain and things like that. So, okay. So while we're here, another thing we can do is probably add holes to this. But I kind of also just want to see what the overall image is going to look like. So we'll finish our sketch and we'll save it. And now the idea is we kind of want something that kind of, rises up and then kind of gently slopes back. Kind of provides a little bit of coverage. So probably the best way to do that, in my opinion, it's going to be to kind of have like a little sweep. So what I want to do is I'm going to come here and I'm going to draw a triangle between our inner and our outer surface. It doesn't have to be large. And what's nice is Fusion is generally intelligent enough that sometimes if we're lucky, we can take these points and we can make them coincident. And that will become important for the next feature that I'm going to be using. Now we can kind of just make this an isosceles triangle. So what we'll do is we'll go here, 0.35. We'll go here, and we'll say that this equals D8. And now this should be a fully defined triangle. Yep, okay. Finish sketch. And now what we're going to do is we're going to use the sweep tool. And now the way the sweep tool works is we want to choose a profile. So we're going to take this profile and we're going to sweep it along these two paths. So this will be the inner edge and this will be the outer edge. So the profile we're going to choose is here, and it's fully enclosed. That's an important aspect of any profile, is they have to be fully enclosed. And then the path, we're going to use a path and a guide rail. So the path we're going to choose is the inside path, and the guide rail we're going to choose is the outside path. And now, as you can see, we're going to make this a new body. We've made ourselves this little swept cap that kind of goes over. And in theory, we're done, right? You could glue this to the top of this and be done, right? That's all you need. But we're going to take it a step further, because now we're gonna put some penetrations in the top for our pegs here, and we're gonna try to put like a little back swept visor that kind of comes back. And then I realize now I kind of probably want a little bit of difference out of my profile here. So I probably want this edge shorter than this edge. So why don't we go 0.125? Let's see. We'll delete these first. I kind of want this. Just so that way the front edge kind of lives inside the visor. So 0.125. And then another thing that we can do is we can actually remove this. And what I'd like to do is I'd kind of like if there was a little thing that kind of came up and back and then met a forward sweep coming up. So we're just gonna kind of raw dog this here, and we're gonna kind of go up and back, and then up and down and over. Up. Let's see. I think that looked okay. Maybe like an inch. Ooh, that's asking a lot. So that it looks something like that. That's kind of what I'm thinking. We're going to make this a little bit more complex. So yeah, 96 degrees is fine. You know, and this is not a particularly exact science. Oop, got an alarm going off. Hold on. And then let's see here. Well, actually, and one thing we can do, 8.5 degrees is fine. 150 degrees is fine. 150 degrees is fine. And then 1 inch back is plenty. Interesting. I think we're also going to need to define this distance. Yeah. 0.15. Okay. Now, what we can do is we can start taking some measurements of our visor, and we can get these a little bit more accurate. So what we want this vertical piece to do is just kind of lift up and over this little lip. So we'll just take a measurement of that lip. Uh, 0.4985. So 0.5. And this is typically what'll happen, is you'll make something, you'll think it's brilliant, and then you'll start taking measurements and realize that it's probably way too small. Pretty typical. And then I want this section to kind of come back at least over the back of this, right? So this is only about a 1/2 inch. So if we go an inch, we're going to be kind of back here, which is kind of what we want, right? That's not really the end of the world. Because that covers the foam, keeps the foam from getting wet. So, and also kind of provides some coverage to the front of your head. So I think that works as an inch. And then this top piece kind of interacts with our visor, so we'll plug our visor back in here. And now again, see, and this is kind of the cap we're trying to make, kind of gives coverage, because this visor doesn't really work for rain. It works for sunlight, but it doesn't work for rain. So now we have to make sure that this upper piece rests inside of the gap between the cap. So we're just going to measure and see how much vertical space we have to work with. It looks like a lot. Let me just go from like here to here. Or 1.25, give or take. So we've got plenty of space to work with. I don't think we're going to run into any vertical constraints here. So we're doing this all with angles. So let's remove this angular constraint. Let's remove this dimensional constraint. Let's remove this angular constraint. So all we really have to stay below is 0.125. And yeah, we're pretty well below that, I would say. So let's go like 3/4 of an inch. Give ourselves some stuff to work with. I don't like this constraint anymore. Let's kind of make this a little bit steeper. Bring this in. Maybe bring this back. Maybe kind of raise it up. That's workable, I think. It's a little complex though. Let's see. Let's cut that. Kind of want an extra gon in my polygon here. Maybe a couple extra gons up here too. Perfect, perfect. It's kind of what I'm looking for, is I'm looking for an edge. I can kind of use to drop those pegs through. Okay, 0.75 to that point. 3.2, 65 degrees. It's just good to fully define your sketches. It doesn't have to be too involved. 97.5, and maybe we can introduce some uniformity here by saying we'll go 65 degrees back here too. Just so that there's some kind of uniformity. There we go. And then 3.35 gives ourselves some extra room to work with there. And then we'll try to go for a little bit of uniformity here, and we'll go 0.2. And that should work pretty darn well. Okay, so we'll finish our sketch, and we'll save it. Okay, and now we have something that is a little bit more organic, and is kind of serves the requirements of kind of this back sloped rain cap. I kind of like this, how it kind of peaks up in the middle here. That's kind of unique and interesting. Didn't expect that from this sweep. But you see how it took all of our inputs from the sketch and applied them straight to the sweep and created a new sweep based on that. So I'm actually kind of very pleased with the way that this looks, because it honestly works very well with kind of the way that we have this little hump in the center, and that whole like upper area can go kind of rest underneath it. So I'm actually very happy with this. And we'll kind of have to see after we've 3D printed it how all this fits together. But that's what we've got right now. So looking at this structure, I can say with some degree of certainty that I think the way that I want to print this is probably like this orientation, with this being the bottom edge, because we're going to try to minimize overhangs a little bit, and we're going to try to maximize the amount of material that can be supported by the material underneath it. So I foresee needing support material like here and here, but that should not be terrible. And we'll get to that. We'll get to that. But this is what we've got so far. So if this is what we're going for, there's a few things that we can kind of do to save ourselves a little bit of material and kind of help strengthen this for 3D printing, especially based on kind of what we just talked about. So one thing that I'm going to do is I'm going to use the fillet tool to kind of round out some of these edges. So I'm going to take this edge, and it does not like that. What about this edge? Interesting. The fillet tool does not like to interact with these sweeps. So we might have to actually put those into the sketch, which shouldn't be too difficult. There is actually, what's nice is in the modify, there are fillet and chamfer tools. So we just fillet, 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 fillet. And this just kind of rounds out some of these edges, kind of helps them support. And if we want to keep more of like our polygon structure, we can even use chamfers instead. Equal distance, chamfer, 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 chamfer. And this just helps add strength while we're 3D printing and for our structure in general. And just kind of helps the stress flow through it a little bit better. and helps it support itself mutually a little bit better. So we'll define this as what, like 0.125. Sure. So we'll finish that. There we go. And yeah, now we've got a little bit more edge. Everything's a little smoother. Yeah, I like that very much. Yeah, and what's cool is like if it's hard to visualize kind of what's going on in the center, what we can do is we can go to inspect and we can grab a section analysis of our center plane. There we go. And now we can kind of see what's going on in the center. So we can see that it is a pretty thick structure once you get to the center. It kind of scales up largely because the space gets so large, but that's okay. It should just mean that it's very strong. And one thing we can do to recover some material is we can just reduce the infill so that it's not as stiff and it's not using a bunch of material to make that. Okay, so we'll save that. And then we'll remove the section because we won't need it for this next part. All right, so now that we've got that, what I want to do is I want to find the rough positioning of our pinholes here. And so we've got them right here, but these are a little bit hard to measure. And we do know that they join in these third holes on the side, and also that they join in this large hole in the front center. So all we really need to do is locate those on our first sketch. So we'll go back to sketch 1. And this hole is pretty easy to locate because we just need to measure back from the front. We can kind of see, and we kind of want a center distance as opposed to an edge distance. That's about 0.575 from the front. So we'll just sketch in a hole. And these holes have a diameter of, what have I done? 0.145 or so. Well, that front one does. The other two are a little bit smaller. I don't know if that's easy to see. So 0.145. Okay, so that's our front hole. And now we have our two side holes. So these are a little bit more difficult to locate, but I think what we can do is we can actually use a we can actually triangulate these. So let's see. We know that the center well, hold on. What did I say? 0.545 or 0.575? Let's go 0.6. I like 0.6 better. Yeah, and it's kind of important to make sure that we measure these holes in relation to each other. Because we need to make sure that this is the one thing where we need to make sure that we're as precise as possible, is in the spacing of these holes. Okay. So now we know, and we can measure directly the center distance between these two holes. So we know that the center distance between the front hole and our third hole from the back is approximately 3.62. So yeah, we have 3.62, and now we know that the distance between the two back holes, the center distance between the two back holes, I'm just going to do this. Let's make a line. Well, let's make a construction line from the center of this hole to over here. Just hitting X to make that a construction. Distance 3.62. Okay. So now we know our other hole is there, and now we can measure the distance between those two holes. About 5.575, or 5.75. So now we know those are 5.75, so what we can do is we can just take the distance here, and we go 5.75 over 2. And if we wanted to be, we could probably even do better. Because we could either mirror this across the center line, or we could just dimension equals that. And then these guys from here to here, 5.75. There we go. And now we have our holes positioned, and we can put our other two holes in. So again, we go back and we measure the diameter of these holes. These ones are about 0.12. We'll go 0.12, 0.125. Want to give ourselves a little bit of clearance because these are going to be kind of a clearance fit at the bottom especially. 0.125. And we'll go 0.15 here. There we go. Okay. So now we'll save, now that we've got those. And now that's a good baseline for our penetration. So we'll probably have to make a couple adjustments based on that new information to try and kind of squeeze everything together. But let's see. Let's get that sketch revealed. Did we get? Oh, we got one, but not the other. 0.125. 0.125. Finish sketch, and then we'll just take all these, and I just want a kind of visual of what we're working with, because I have a bad feeling. Actually, that didn't turn out too bad. Okay. Yeah, that's workable. So right now we have these guys coming through right here, and I kind of want them out here in the web, but that chamfer is kind of getting in the way of that, and our top piece is kind of getting in the way of that. So there's a couple of things that we can do to kind of make a change there. So let's come in here. We're kind of working with all these chamfers now, which kind of makes this difficult. But we do have some room to work with. So why don't we take this and go 0.45. 0.4. 0.15. 0.15. Just kind of making this a little thinner. 0.60. Oop. 0.7. And then let's remove this chamfer. Rejoin these two points. Now we kind of want to change this back sloping here. Point 0.4, 126.14. So this one's this front one, this one's this back one. Let's kind of move this stuff around. I'm doing a little bit of mental math here to figure out how this front slope is defined. There we go, and I'm just going to rock that back a little bit. Redefine that. Probably do the same thing with this bottom one. Rock it back. Redefine that. There we go. I'm a little bit happier with that. So let's save it. Let's see if it can resolve that, and it did. There we go. So now our holes are out on the webbing, and this is sloped in a little bit more. Okay. And that's just a lot more workable generally. Okay, so now we need to basically ensure, and this is where things get a little bit more complex, is that we have a snug fit for these pegs to go into. So I know that these, when they're in, go a little bit past the datum surface, right? Because they snap in. So let's snap these back in and see. I believe that they just go into this first channel, and so everything above that first channel is probably going to be above our datum surface, but let's just make sure we're not going crazy here, because you can't go someplace you already are. Okay. So yeah, it looks like it went into that first channel, and then these back pegs only have one channel. So now we know what goes in and what stays out. And so now here is where our project kind of starts interacting with the piece again. So we know that everything above these channels is what is going to be above our datum surface, which means that's what's going into our hole right here. So we need to make sure that this hole is shaped just like the piece that it's interacting with. So yeah, that's our project. So to begin with, let's redefine these hole diameters with a little bit of clearance, probably about 1% of clearance of these holes right here. So let's redefine these hole diameters. So the front one is no longer going to be what it was. It's going to be 0.18 times 1.01. And that will give us some clearance. And the reason we need that clearance is, one, so that we can get the peg through the hole, and two, because 3D printing is not precise. And we need a little bit of extra clearance just to make sure everything fits together. Now I realize this little nubbin might be a little bit wider than that, so let's just double check that. Now we're about 1.8 on the end as well. So now we'll do this for the other two pegs. So back here, we're about the same, 1.8. So it's good that we double checked this because this probably would have been a real problem. So these become the same, 1.8 times 1.01. Adding, oh, how about 0.18 times 1.01? There we go. Same on the other side, 0.18 times 1.01. All right, and so now that is our first hole. We can actually collapse this panel, I think. There we go. Yeah, so again, we're interfering a little bit. It's getting a little tight in there. I think we're okay with some of our sloping. Okay, so now here's the other critical piece. We need to know how much is interacting. So the front is different from the back. So let's take a measurement and let's just see the maximum distance from the top to the bottom, or just the distance. So we interact with about 0.37 inches of this peg from this top surface up. So about that much of it. So we can see, based on that we have a little bit of travel where it's just a cylinder, and then we start having to deal with the flutes. So we'll have to model those flute slots into this to get it all to rest well together. So let's get started here. So let's get our section back up. You can click this little orientation cube and that adjusts your orientation based on the area that's highlighted. We're going to use that. We're going to create a new sketch. This is our center plane. And now we get to work with this. So we'll need a line. Here. We'll want the midpoint. So again, this is our wonderful 0.18 times 1.01. And now, I don't think that I can make it coincident with an arc, unfortunately, and I can't make a tangent, but we can make this a midpoint. Or we can put a point there and make that our midpoint. Okay. So we're going up 0.37. And our first .14 inches is a cylinder. And same on the other side. Okay, and now we have to deal with our fluting. So the fluting, and we're going to do this actually pretty easy to do. It goes up to 0.37. So we'll get back up there to 0.37. Okay. And now that we know where that is, we'll just take a measurement right about there. And we're about 0.29 for what it is. We'll go 0.3. So we know that by the time we get to the top of our plate, this distance should be about 0.3. And then we'll put a center construction line through the middle here. We'll make it coincident with our midpoint, and we'll midpoint this line. There we go. And so now we know our fluting kind of goes up from there to there. Whoa, Black Betty, Bambalam. All right. And now, yeah, that looks pretty good. I actually like that. We might be onto something here. Okay, so now we get to do some really interesting things. So we don't really need to cut anything out down there, which is nice. So I think all we really need to do is just extrude and then circular pattern. So extrude, and now what we'll do is we need that to continue being our midplane. So let's see how thick these flutes are. About 0.065, 0.055, 0.05, 0.055. So we'll go two-sided, distance 0.055 over 2, distance 0.055 over 2. Now I don't really want the whole thing to do that, so we're going to say okay. But then we're going to kind of go back and make some changes here. Honestly, does that interfere? So we have some imperfections here, but does that interfere with our end use? Probably not, but we can do better. So let's go back in here. And we're just going to kind of cordon off this. So that way when we do this extrude, we just remove that. And all we're left with is our little side flutes, like that. And then extrude, just to cut out all these imperfections. Actually, this might need the delete tool. The delete tool is a little bit more versatile for this kind of work. Here, okay. I say as it completely fails me. Okay, extrude it is. So extrude, extrude. And we're just kind of cutting out all the stuff that we don't really need. Now can we delete that? What a crazy artifact. Okay, maybe because we're trying to click on this section. It's so funny, it only exists from that angle. Okay, we're gonna ignore that, and then extrude. All right, and then we'll remove our section because we might have to do that on the other side as well. It looks like we do. And then up from underneath. And maybe we can delete those. Okay. Life's good. All right. Yeah, now, yeah, this is kind of a messy way to clean up, but again, this is kind of an organic piece. Um, so we don't, yeah, sometimes it just happens this way for some of these more complex things, especially, yeah, if things don't line up perfectly and stuff, you gotta kind of do what you gotta do sometimes. So we can take this and we can circular pattern it. And honestly, that's probably the way we should do this, now that I think about it. And this is kind of the way it goes, is you're like halfway through and then you're like, oh, well, I can do it this way. So really, if you think about it, all we have to do is extrude this one side. So 0.55 over 2. And then the other way, 0.55 over 2. And then we can just kind of make some adjustments to the sketch to kind of make everything a little cleaner. So this should be above, and this should be beyond. And there we go. Okay, a little bit further beyond. Point 0.32. Perfetto. That's what you want right there. Okay, and now we can hide that, And now, without all that mess, we've cleaned all that up, and we can take this feature, and we should be able to circular pattern it. Feature. Axis, select our cylinder, and we want 4 of them. Bam, and now we have our flutes. And that was 1,000 times better than all of that cutting and stuff. This is much better and much cleaner. So yeah, I mean, that's good. We're almost done. We just need to put the fluting in these other 2 holes, and then I say I'm just going to 3D print this and test it, because I'm honestly really pleased with this already. So yeah, let's do it. All right. There might be a way we can copy these features over into those other holes. This kind of gets to something that I haven't messed with before. Aha, but I've got it. Okay, we're going to circular pattern the crap out of this. Okay. Let's see now. So we've got our sketch here, right? So what we're going to do is we're going to make a cycle. And this cycle will go through all of our points. And it will be a construction cycle. Oh, weird. Oh, no. Okay. Let's take, and we'll put a line here, make it construction, and then make it horizontal. Bam. Okay. Now we can take this circle, make it coincident with the center point there, and bam. Look at this. We're artists. True artists. Okay, now finish sketch. Reveal that. Sketch 1. Okay, now create circular pattern with features. Here and here. The axis we will choose to be this. Distribution partial. Two. Now I don't want the angle to be 180 degrees. I want it to be this angle, so we got to measure that angle. So back into our sketch. A couple more, actually. No, silly. A couple more construction lines from here to here. And that is 74.8 degrees. Sorry, that is that 70. Yeah, all right, we'll get a calculator. 105.159 minus 180. 74.841. Back to our pattern. Partial. 74.841. And we only want 2 of them. And then our objects. I have made a terrible mistake. Save it. Pattern, circular pattern. objects, axis, two, partial, 74.841. Wha-bam! And that's our fluting on one side. As you can see, it kind of cuts into our thing here, but that should be okay. We should be able to survive that, I think. And there's some things that I can do to kind of help with that as well. But then we need that on the other side. So another circular pattern. Same thing on the other side. Two partial minus 74.841. Bam. There we go. Yeah, I'm very interested to see how well this is going to work. But that's what we got. So now what we'll do is we'll just kind of chamfer away this little shelf as best we can. Do the same thing on the other side. There we go. Just give ourselves a little bit of clearance and send. Okay. Now let's go ahead. We're going to open up FlashPrint. Before we get there, though, let's save. So we've saved, and now we go 3D print. We'll export, and we want, I prefer STLs. I think binary is probably fine. Unit type inch, structure, one file. What's cool is we can preview our mesh and kind of see what it's going to look like here. Which this is a pretty detailed mesh. Kind of curious. I'm pretty happy with that. Yep, and that just makes sure that our mesh kind of looks good and looks like what we've created in 3D space. Yeah, very happy. Very happy. Okay. So we'll save it as the same thing. PB, actually, we don't save this to Fusion. We save this here, and I have a special folder for all my STLs. And then something we can find, like something wild and crazy, like PB goggle rain cap. Save. Save. All right, and now we can go to Fusion, and we can open this up. So I just got like some new software for my Guider 2, and I'm still figuring it out. But we just load the file, go to STLs, and then find our crazy name. There we go. And it's all tiny because it thinks that we're talking about millimeters. So we have to scale it first. This is a very important number, 2,540. Gets us to the right size. And then we rotate it. And we want this face to lay flat. Like so. I was afraid you were going to say that. It's not quite 90 degrees, but that's okay. Because we'll probably just add supports and still print from this side. Okay. So that looks good. Now, no need to scale, cut, no duplicates. Support. We want vertical supports, overhang threshold. 65 degrees is pretty standard for me, but that can vary. Touch platform only, auto supports. Bam. And that's what we get. So those are all of our support materials, and that just makes sure that that back surface is nice and structurally sound. Okay, and then back, and that should save it. And now another thing. One thing this printer likes to do is it likes to add a raft without asking me if it wants to add a raft. So PLA 210 is a little hot. Let's go 200. General shells. We're going to keep the raft enabled though, because more and more I kind of like having a raft. So let's slice this and see what it looks like. Take a look at our preview. Here's our raft chilling. Here's all of our layers. Now I did not check my infill, so there's a good chance that we'll probably have to double that back, but we can also cycle down through our layers and just preview what they'll look like. That looks like good infill. It looks like that infill's already at like 10 or 20%, which is kind of what we want, kind of all we need for, you know, a rain fly like this. Yeah, and I'm really pleased with this. I think this is kind of exactly what we're looking for. So we are gonna rip, ship, and send it, dude. All right, so now I need to run back and grab my flash drive. All right, we grabbed the flash drive. We've got it plugged in. So now what we'll do is we'll save this. I've got a folder for G-code, so we'll just pop it in there for now. And then we've got our external drive. So we'll go to G-code. Come on. Copy. 3D printing files. This is where I keep all the G-code for my Guider 2. Paste. All right. So now that's where I'm going to end this video, is all the software side. I'm going to do a quick probably video just on taking the flash drive, putting it in the printer, and running it. I'm not going to show any setup, but just kind of how we get to starting our print. So yeah, if you made it this far, thanks so much for watching. I hope you learned something from this. I know I sure did. I really enjoyed making this. It's kind of an interesting project. I'm fascinated to see how this turns out. We'll probably have to make some adjustments just based on kind of how hastily we did this. But yeah, we'll see how it goes. Thanks a lot for watching.